Over the past 2 decades, the military roles and contributions of unmanned vehicles have grown dramatically, and this trend appears likely to continue. However, unmanned surface vehicles, USVs, maritime vehicles uninhabited by personnel that maintain continuous substantial contact with the surface, have received less attention and investment than unmanned vehicles that operate in the air, on the ground, or under the sea. But in recent years, unmanned surface vehicles have become increasingly important for military operations. After a bruising year-long fight with Congress, part of the Navy's plan to field unmanned ships appears to be on life support, making 2021 a crucial year for plotting a path forward. Therefore, U.S. military leaders are getting serious about developing unmanned surface vessels for jobs like the global transport of military cargo, moving troops and support personnel, anti-submarine warfare, maritime surveillance, and even offensive operations against enemy ships. On September 17th, former Secretary of Defense Mark Esper said, "Unmanned will enable us to grow the United States Navy well beyond 355 ships. It will add more lethality, survivability, capability, etc. to the United States Navy and indeed to the joint force. So we're making all those investments. The research and the development budget that we had this fiscal year is the largest in history. We're very excited about that. We have to invest in the future." Before moving on to how they could fit into the current fleet structure and how concerns surrounding command and control will affect different potential mission sets, while unmanned undersea vehicles will also bring important changes, they are beyond the scope of our discussion today, which focuses only on USVs. While USVs have the potential to change the Navy, fleet structures cannot simply be replaced but will instead evolve over time. Rather than dream of a hypothetical new fleet structure, we must understand how USVs will fit into the existing one. So we will discuss it more in 3 important parts. Number 1. Current program. The Navy has already created several platforms for testing and integrating autonomous USVs. The Ghost Fleet Overload program has completed its first phase, conducting 600 hours of autonomous navigation with 2 converted commercial ships. And its second phase is currently testing C2 integration and payload systems. Additionally, 2 Sea Hunter autonomous ships are undergoing testing with the Navy's Surface Development Squadron 1. These ships, initially developed by DARPA, are capable of continuously shadowing enemy submarines. And while not autonomous, small remote-controlled USVs are already in use as supporting vessels for the littoral combat ships, carrying out scouting, countermine, anti-submarine, and electronic warfare missions. For future procurement, the Navy has designated 2 acquisition programs: Large Unmanned Surface Vehicles, LUSVs, and Medium Unmanned Surface Vehicles, MUSVs. MUSVs would be 45 feet to 190 feet long and tasked with intelligence, surveillance, and reconnaissance payloads and electronic warfare missions. LUSVs would be 200 feet to 300 feet in length and be more offensive in nature, armed with anti-ship and land attack missiles. The Navy's desire to employ these accelerated acquisition strategies can be viewed as an expression of the urgency that the Navy attaches to fielding large UVs for meeting future military challenges from countries such as China. Both programs are designed to be crew optional, allowing for a small crew to remain on board for missions where more hands-on oversight or decision-making might be needed. It also allows for a kind of overlap period where a human presence is maintained while technical and ethical issues surrounding command and control are worked out. This is by no means an exhaustive list of prototypes and programs, but should demonstrate the kinds of technical capabilities the Navy expects USVs to have in the near future. Number 2. Command and control. What would command and control look like, and how does that affect the potential uses of USVs? To receive instructions, every system will need at least one of the following command and control systems, or some combination of them. Autonomous control allows for maximum decentralization, expandability, freedom of design, and minimal operational costs. It also does not require any outside connection to operate, which may be unavailable or undesirable in an electromagnetic contested environment. However, while AI systems are improving rapidly, they are still a work in progress, and their ability to react to more complex situations may be limited. Furthermore, remote control allows for many of the benefits of autonomous control, but with humans in the loop on the other end of a network connection. This system of control is already in wide use with unmanned aerial vehicles such as the MQ-9. Ethical concerns remain that remote control systems desensitize operators to violence and lead to unnecessary collateral damage. Though as it stands now, this existing use case provides a strong precedent for how remote control might be used at sea. However, remote control requires a dependable, robust connection which may not be available in an electromagnetic contested environment where communication signals could be jammed or could give away the location of the ship. In this situation, the system would either need to revert to autonomous controls or simply become a floating husk. Human sailors can operate electromagnetic independently without sacrificing system oversight. In the context of USVs, this would mean ships which perform most tasks themselves but retain a tiny crew to perform key command, control, and oversight tasks. In some ways, this is the best of both worlds. However, such crew-optional or lightly manned ships still severely limit some of the potential gains from USVs. One of the benefits of USVs is that they are more easily risked in dangerous environments. But the minute you put a single human sailor aboard, that risk tolerance understandably plummets. Additionally, the need to house humans constrains ship design choices and operations, putting limits on just how small, streamlined, and decentralized the systems could reasonably be. This set of options and trade-offs will affect each potential role differently. Due to the diversity of mission sets and requirements, a one-size-fits-all approach to new command and control systems will not sufficiently meet the needs of the future Navy. Number 3. Potential roles. How and where both unmanned and autonomous capabilities will be used is a much more open-ended question. When dealing with new technologies, there is no roadmap, and predictions on how novel capabilities will be implemented can easily become lost in speculation. But to determine how USVs will be used initially, it is helpful to fit them into an existing framework of naval operations. One of the most authoritative books on the subject of modern naval tactics is Fleet Tactics and Naval Operations by Captain John Hughes. In it, Hughes lays out 4 categories of naval forces: battle fleets, cruisers, amphibious forces, and flotillas. At the end of this video, we conclude that with or without lethal autonomy, USVs of all shapes, sizes, roles, and control systems will soon be making a large impact on the world's navies. As with many emerging technologies, the potential ramifications of unmanned systems can seem overwhelming, almost limitless. Imagining the myriad possibilities can be both useful and entertaining. But it's important to remember that these systems will come into being over time. And as they do, they will work themselves into the existing structures and frameworks. Evaluating USVs in this light can help us bring semblance of order to the chaos that often accompanies rapid technological change.